Hello everybody, welcome to Simplilearn's AWS S3 tutorial for beginners. My name is Kent, and today I'm going to be covering these following points. I'm going to be covering what is cloud computing. I'm going to be showcasing what AWS is in terms of cloud computing, and I'm also going to be covering the core fundamental service of the Simple Storage service, which is a object storage service. We're going to be covering the benefits of the Simple Storage service, better known as S3, what objects and buckets are, and we're going to be seeing how things are working in the background and implementing that in terms of lab assisted demonstrations in order for you to see what those features of S3 are. And then we'll perform a wrap up of the material we've done in a conclusion. So let's get started. What is cloud computing? So here is a definition of cloud computing, but I'm going to paraphrase it. Cloud computing is nothing more than you gaining access to infrastructure through web services with a pay-as-you-go model. Now, this is a very, very different model than we're traditionally involved in on an on-prem data center. So when I mean on-prem, I'm saying on-premise. Okay, so you'll hear that a lot, on-prem. Now, when we are on on-premise data center, we have to provision lots of infrastructure even before we get started with deploying any type of application, whether it be a mobile application, a web application, etc., etc. So every application needs some sort of underlying infrastructure, whether that be bare bone servers, databases. They're obviously going to be needing some types of storage, etc., etc. So all this is something that we have to kind of fight against in order just to get started with deploying our application. So this takes usually, traditionally, depending on the size of the company, about 3 months to set up. So what if we could leverage all this infrastructure as a service and just through some API call, that's what the web services is all about, we could provision a server or we could provision a database within minutes and then deploy any type of application that we want to on top of that stack, and also take advantage of any storage that we may want. We may want object level storage, which is what we're going to cover. We may want an elastic file system, right? So there are different types of storages that we're eventually going to look at as you go down your learning path with Simplilearn. So cloud computing is really about provisioning of all these kinds of services, but not only at the infrastructure level. We're going to see how we could move up the stack and get entire platforms as a service or even softwares as a service. So what is AWS? Well, AWS is really a cloud computing platform that will offer us many, many services through these API calls. Some are, again, just bare infrastructure like a service. Other can be a service as a software, for example, email. So here we have an example of the public data storage. This is S3, the simple storage service icon that you're going to see over and over again. This is a representation of an actual bucket in S3. So this will become more clear as we continue the slide deck and actually reinforce this with some hands-on lab. But as you can imagine, you may want to provision a private software-defined network in the cloud. And so we can do that in AWS. We can provide load balancing. We could provide scalability in terms of auto scaling groups that will respond to increased demand as your application, let's say, becomes more popular. You want that infrastructure to grow elastically. So doing this on premise is traditionally not only extremely expensive and thus prohibitive, but very difficult to implement physically speaking as well. So by going with a cloud provider like AWS, we can severely reduce the expense and the complexity of setting all of this up because we're trading capital expense for variable expense. So capital expense is about you procuring all the hardware that you need beforehand and the budget being approved before even getting that hardware in through your door, right? And then you have to configure it. So there's that complexity factor. Whereas if you're doing this through AWS, you can within minutes just provision all of that very quickly. So you're also not paying for everything all up front. You're paying this with a pay as you go model. So very different. We're now removing what's called undifferentiated lifting, which is everybody has to do the same thing, but it's not really bringing any value to their end product. We all have to buy servers and configure them and scale them, etc., etc. So if we remove that element and have AWS handle that, we can concentrate on our business, which is our application, and improving that application and responding more to our clients' requests. We can be more agile, more flexible. So all of this leads to these points that we see here on this slide. Much easier to use, much easier to get our application to market. We're actually going to be leveraging the physical security that AWS implements for us. They have data centers all over the world that we're going to plug into, and that physical security is already implemented for us. There are varying levels of security that we're going to get into through our AWS journey, but right off the bat, you know that you have physical security. Of course, we're going to be talking about storage in this demonstration or in this slide deck over here. But the nice thing is we only pay for what we use. So that's that variable expense that I was talking about that we've traded for capital expense. We can easily set up databases. We can easily automate our backups and have those backups stored in the cloud through that S3 storage that we're going to get into. Okay. So lots of benefits of going through AWS here. And it's also comprehensive and simple to use. Comprehensive meaning that there are hundreds and hundreds of services. It's going to be actually quite time consuming for you to just know what each service does in general, but you'll get there through your journey. It's all about sticking with it and learning something new every day, which is what Simplilearn is all about. Over here, we have infrastructure as a service, platform as a service, and software as a service. So these are three different types of distinctions we have in the cloud industry to basically cover what's going on here on the right-hand side. So on-premise, you're traditionally involved in everything from networking, which is you, for example, buying the switches, the routers, the cabling, everything all the way up the stack to deploying your application, and you see everything in between there. Okay, so this is a very time-consuming job. Not only that, but it costs a lot of money because you have to buy all these machines up front, and you have to have the individuals with the right knowledge to maintain all of this stack. All right, so different individuals in different teams maintaining this whole on-premise data center. You may also have different data centers deployed globally. So you can imagine the cost overhead of this. So everything in green is basically you're managing it. Now we can offset that and ask AWS to handle part of this stack over here. So on this second column over here, we see infrastructure as a service, which basically says, AWS, I want you to handle all the networking, my software-defined network. I want you to handle my storage, elasticity. I want you to handle my compute power, my virtual machines. I want you to handle even administrating those machines at a physical layer as well. And I want you to physically secure them. So this will allow you more time to focus on all the green up here. Of course, we can move up the stack and say, I even want AWS to take on more responsibility. And that would be more of a platform as a service where AWS would also install and maintain the operating system for you. So you can imagine things like new versions of operating systems, security patches, maintenance patches, all of the like, and any middleware or runtime that you have on top of that. Think of something like the Java virtual machine, perhaps, that needs to be updated. Now, you wouldn't be responsible for maintaining all of what's in orange over here. You would only be responsible for deploying your application and making sure that your data is saved and secured, right? So again, platform as a service is a more hands-off approach. So think of it as you wanted to set up a CI/CD deployment environment for your development team, and you wanted to be very involved in just handling your application code and making sure that it was properly compiled, built, tested, and deployed, right? Well, this could be implemented as a platform as a service. Or you could take your code as a zip file and give it to AWS's service called Beanstalk, which would automatically deploy your code and make sure that it's highly available, scalable, and fault tolerant across all of the orange stack over here, right? So more of a hands-off approach. Of course, we can go all the way up the stack and tell AWS to take care of everything for us and just ask for a service, much like a utility, like electricity or water. We might want to say, we just want an email software service, and we're not really concerned about how the underlying operating system or servers or network are configured for that. We just want to use the software as a service. We don't want to administrate anything else. We just want to be sort of like an end user to it. So AWS will manage everything underneath the hood. So there are varying types of services. You pick and choose whichever one makes more sense for you and your team. So what is S3? S3 stands for Simple Storage Service, and it is an object storage service in Amazon. What this means is that it doesn't matter what kind of file you upload to S3, it will be treated as an abstraction, meaning an object. So you can upload a PDF file, you can upload a JPEG file, you can upload a database backup. It doesn't really matter. All that is abstracted away by the use of storing it within an object. We're going to talk more about what composes an object, but by doing so, what happens is S3 allows us to have industry leading scalability. So it doesn't matter if you're going to make a request for that database backup, let's say that object, 5 times or 10,000 times. That request, that demand will scale. The underlying infrastructure that is implemented behind the scenes is handled for you. So in a sense, it's kind of like a serverless service, a storage service where you're not implicated in handling anything underneath the covers. You're just uploading your objects and accessing them later on. In terms of data availability, very powerful as well, because it takes those objects and will replicate them across at least 3 availability zones. Of course, these availability zones have 1 or more data centers attached to them. So you have lots and lots of copies of your objects distributed globally, or at least at a regional, in a regional area. You can do this as well globally if you enable global replication. And you will see that your level of durability will skyrocket, and you're just not going to worry about losing an S3 object. Data security, well, we can encrypt our data at rest, our objects at rest. We can encrypt it in transit. We can also come up with security policies at the bucket level, which we're going to talk about what a bucket is very, very, very soon. These are going to be implemented through what's called IAM policies, and you're going to be able to control who or what has access to your objects. And of course, because everything is handled underneath the covers, all the servers, all the storage nodes are cloud optimized for the best possible performance. So let's continue on our journey on what is S3. We're going to take a look at what is a bucket and what is an object. As you can see here, you have inside this bucket, which is a logical container for an unlimited amount of objects. You could have objects of different shapes and sizes. Like I said, you could have pictures, database backups, etc. So this is what's being represented here by different shapes. And you can think of a bucket really as almost like a folder where objects or files are placed within them. So there are many ways for us to place objects within a bucket. We can do this through the AWS console, which I'll be showing you very shortly. We can do this via the command line interface, or we can do this through a software development kit. At the end of the day, all those three options go through an API, right? So it's all about picking the right method that is best suited for whatever kind of end user or application that needs access to these buckets and to these objects. Now, once you've got the data or objects within this bucket, you can control pretty much how the data is accessed, how it's stored, whether you want it to be encrypted, and how it's even managed. So you can have organizations that have specific compliance needs. For example, any objects that are placed in there, perhaps some PDFs, are not to be modified or not to be touched for 90 days. Let's say we can imply object locks if we want to. We can imply security guards. We can also, for example, record all API actions that try to access, to list, to delete any kind of API operations on those objects at the bucket level or on the object level. We can record if that is some sort of organizational compliance need for auditing or for whatever internal auditing reason that you may have. So continuing on here, you can see that there are many organizations that use S3. One in point is Amazon itself. S3 is so popular and so durable that Amazon internally uses it to store its own data. You're guaranteed, almost that you're not going to lose any object in there because it has what we call 11 nines durability. Now, 11 nines durability is really an extreme amount of durability where it's mathematically almost impossible for you to lose an object once you place it in S3. You're in fact more liable to get hit by a meteorite than you are to lose an object in S3, statistically speaking, which is a pretty incredible statistic, but it's true. So if we continue here with the benefits of S3, some of these I've already described, but let's talk about the full picture here. We see the performance, scalability, availability, and durability of S3 are really first class in the industry. Again, durability, we were talking about that 11.9. So what that really means is 99.9999 in total. If you count all the nines, that's 11 of those nines. So most durable in the industry by far. And again, because everything is handled underneath the covers, it's a serverless service. They ensure the scalability and availability and the performance of the inner workings of that object level storage. Now, cost is of course always important, and S3 really shows up here with first class support again for cost. It's got very, very low cost. We can have object level storage for let's say a terabyte of object level storage for as little as $1 a month. So again, it will depend on the kind of storage class. We're going to have a discussion on different types of storage classes that we might want to transition or move over our objects from one storage class to the next, depending on how frequently accessed that data is. As you know, data over time seems to get less and less accessed as your needs shift from one place to another. We're going to talk about that coming up very soon. So we're going to want to really focus on that to reduce our end of the month costs for storage with S3. Of course, security is always at the forefront, and we want to make sure that we either simply secure by encrypting everything right off the bat, either at rest, in transit, or we want to put an object lock or just maintain security at the bucket level, maintaining, let's say, who or what has access to that data. Because by default, no one has access to the data unless we open up the door. And also we want to make sure that we don't give public access to our bucket for obvious reasons of giving away important information by mistake. So AWS makes it extremely difficult for you to accidentally do this. And I'm going to show this in a demonstration lab coming up very soon. And we can also query in place, which is very interesting. So you can imagine you putting, let's say, a file that's in CSV format or a JSON format or Parquet format, some sort of structured format or semi-structured format in S3, and you can actually use SQL queries on the spot to filter that data in place at the bucket level. You could also have other services that may want to extract some business intelligence from that data in your S3 bucket directly as well. So some other more advanced querying operations can take place at the S3 level. So this you will learn during your journey with Simplilearn as you're covering all the AWS technology stacks. And here, the most widely used storage cloud service in the industry. Because of all the points that we just covered, it really is the #1 storage or object level storage solution in the industry. Let's now take a look at objects and buckets in S3. So the objects are really the fundamental entities that are stored in S3, or the lowest common denominator, which means that we're not really interested in what kind of data is within the object at the layer of S3, because S3 doesn't have direct access to the data within an object. Like I said before, it's an abstraction of the data. So we don't know if it's a cat picture, if it's a backup of your database. It's just treated as a fundamental entity, aka the object. Now, every object is associated with metadata, so data about itself, things like what's the name of the object, what's the size, the time and date that the object was uploaded. Things of that nature are categorized as metadata. So S3 does have direct access to that. Now, the data within that object, of course, is accessible by other services. So it's not that once you've uploaded it, you've totally lost the data and it's only can be treated as an object. It's just that at this layer, it's simply just assigned metadata and a version ID, a unique version ID. And if you re-upload the exact same object a second or third time to S3, it will have its own version ID number. So a new unique version ID number will be generated. So really what buckets are their logical containers to store those objects. So of course, at an extremely high level, a bucket would be like your root file system, if you want to think about it like that. But that doesn't mean you can't go into this bucket and create separate folders. Now, when you create separate folders in a bucket, because you might want to logically organize all your objects, you might be fooled by the fact that you think this is a hierarchical storage system, when in fact it is not. And I'll talk about that in a second. So you cannot store an object without first storing it into a bucket. So of course, the first step would be for us to create a bucket and then upload objects within that bucket. So an object cannot exist without its container or its bucket. So there's no Windows Explorer view like we're used to in an operating system, because this is not a hierarchical view. No matter if you create folders within folders within folders, in fact, S3's internal architecture is a flat hierarchy. What we do instead is we assign prefixes, which are treated as folders, in order to logically organize our objects within our buckets. And I'm going to showcase a prefix in one of the demonstrations coming up very soon. So when you create, or when you're working with S3, first of all, you're working at a regional level. You're going to have to pick a region. For example, you might pick US East 1 region or US East 2 region, and the bucket that you're going to be creating will be replicated across several availability zones, but within that region. Also, that data, those objects, can be accessed globally, because S3 uses the HTTP protocol. HTTP protocol is very permissive. Everybody knows how to administrate it and work with it. So we just need to give access to that object in terms of a permission policy and give it the proper URL, or give whoever needs access to it the proper URL, and they can access that via HTTP globally. So first, when you're creating a bucket, you have to select the region, and the object will live within that region, but that doesn't mean that it still can't be accessed globally. So let's now take a minute, go over to the AWS console, and actually let me showcase how to create objects and buckets. So for our first lab, we're going to be going and creating an S3 bucket and uploading an object to it. So we first have to log into the AWS console, which we have up here in the address bar. Let's click on either create free account if it's your very first time, or as is in my case, already have an account, and we're going to sign in here. You're going to have to pass in your IAM username, password, and your account ID, of course. Once you've logged in, you can search for the simple storage service S3 either by coming up here in the search box and typing S3, and you'll find it there. That's probably the easiest way. Or if you want, you can take a look at all the services and it'll be under storage over here, the first one. Okay, so pick whichever method you see best for yourself. Once we're here, we want to create our first bucket. Now I've already have a couple of buckets here, so we're going to go on and create a new bucket. The very first thing is you have to specify a bucket name. Now this bucket name has to be globally unique. If you take a look here at the region that we're in, it doesn't actually select a specific region. It selects the global option, which means that this bucket will become globally accessible. So that is why it needs to have a unique name, much like a DNS name has to be unique for your website, right? So I'm going to come up here and pick a name that I think is going to be unique. So I'm going to say Simplilearn S3 demo. All right, let's take a look at if that's going to work out. Of course, we have to pick a region, but it is globally accessible. So you either pick a region that's closest to your end users, or in our case, since we're just doing a demonstration, we can do whichever is closer to us right now. Okay, and we're going to skip these options for now. We're going to come back to them later on. We're just going to create the bucket. Now hopefully that was a unique name and allowed me to create that, and it looks like it did. So if I scroll down, you can see that it clearly got created over here. Now we're going to click on that and we're going to start uploading objects to this bucket. So let me click on the upload button, and you can either select one or more files, or you can select an entire folder. So I'm going to just go and select a specific cat picture that I have here. Okay, and again, we'll go through some of those other options later on, and we'll just click upload. Now this should take no time at all because of the fact that it's a very small object or file that's being uploaded. So it has succeeded. We can close this up. And we see now clearly that the object is in our bucket. If we go to properties, we can see the metadata associated with this bucket. We can see the region that it's in. We can see the ARN, which is the Amazon resource name, which uniquely identifies this resource, this bucket, across the globe. So if ever you needed to reference this, let's say in an IAM policy or whatever other service needed to communicate with S3, you would need this ARN. It's a very important piece of information. And of course, we have the creation date. Some high level metadata. So objects, as we have covered already, consist of not only the data itself, but the metadata. So there's lots of metadata, and there's a lot of other features that we can go here and enable very easily. And this will be the basis of the future demonstrations that I'm going to do. All right. So just to recap what we just did, we created a unique bucket, give it a name of Simplilearn S3 demo, and uploaded our first object to it. So let's now take a look at the inner workings of the Amazon S3. When we upload an object into a bucket, we have to select which one of these storage classes the object will reside in. So you see I have 6 storage classes here at the bottom, and each have their own characteristics that we're going to get into. By default, if you don't specify anything, it'll get placed in what's called the S3 standard storage class, which is the most expensive out of all these storage classes. Once your object gets colder, and what I mean by colder is your access patterns diminish, meaning that you're accessing that file less and less over the course of time, so it gets colder, you will transition that object from one tier to the next, all the way to, for example, S3 Deep Archive. So again, Deep Archive signifies extremely cold, so maybe you're only referencing this data once a year, once every couple of years. And so you want to have the cheapest possible storage available. So right now you can get about 1 terabyte of storage per month for about $1 a month with S3 Glacier Deep Archive. So you are going to be very interested in knowing how to transition from one or more of these storage classes over time in order to save on your storage costs. That's really why we're doing this. So let's go through some of these storage classes. By default, like I said, whenever you upload an object, you automatically get placed into the standard storage class. So any files that you're working on frequently, daily, this is the best fit for it. You've got the highest level of accessibility and durability as well. Not that the others don't have the same level of durability. However, we'll see how when you transition from one storage tier to the next, some characteristics do change in order for you to save on some costs. We're going to go through some of those. Now, this would be considered hot data, right? Data that's used all the time, maybe just by you, maybe by everybody, right? So that's the perfect place to place it in the standard storage class. Now, over time, like I said, you may find yourself working less and less, perhaps on a document that was due by the end of the month. That document was submitted, and then afterwards you don't work on that document anymore. Perhaps you're only working on revisions based on feedback from your colleagues that are asking you to make some corrections or some amendments, and so only those corrections or amendments come in perhaps once a month. And so in that case, you might find yourself finding a justification for moving that document from the standard tier to the standard IA, or infrequently accessed tier. Maybe any objects not modified for more than 30 days are a good fit for that. And that's really the criteria for IA, inactive access, is that S3 or AWS itself recommends to only put objects in there if they haven't been accessed for at least 30 days. So you get a price reduction, a rebate for putting objects that are not accessed frequently in here. Of course, if you remove objects, let's say before the 30-day limit, then you are charged a surcharge for retrieving an object that you said was infrequently accessed, but it really was not. So bear that in mind. If you're going to place objects in infrequent access, be somewhat reasonably assured that you're not going to be going there and accessing them. You can still access those files, no problem, just as quickly. They have the same level of accessibility and durability. However, like I said, anything less than 30 days, you'll get a price ding on that. If you want to have long-term storage, we're talking about Amazon Glacier. So this is more anything over 90 days that hasn't been modified, or 180 days. There's 2 subcategories of Amazon Glacier that we're going to get into. And this is the cheapest storage by far. And Amazon Glacier doesn't really operate through the AWS console as the same as the standard and the infrequent access. You can't really upload objects to Glacier via the console in the browser. You can only do so, let's say, through the command line interface or through an SDK. The only thing you can do on the web console with Glacier is actually create what's called a vault which is a logical container for your archives. But then after that, you have to go through the CLI or the SDK to do the rest of the work there. If we continue on, there's some gray areas between the S3 standard and the Glacier. One is the one zone infrequently accessed storage class. So if we go back to the regular standard and IA storage class, all of these objects are stored across a minimum of 3 availability zones. If you want a further price reduction, you can store your objects in a one zone IA storage class, which means that instead of taking that object and replicating it across 3 or more availability zones, it will only store it in a single availability zone, therefore reducing the level of availability that you have to that object. So in this case here, if that single availability zone would go down, for example, you would not have access to that object. Once it would come back up, of course, you would. The other thing is if there was an immense catastrophe where the actual availability zone was destroyed, well, of course, then your object is also gone. So if that's something that doesn't worry you because you have already many copies of this object maybe lying around on premise, then this is a good option for you because it's data that you're willing to lose or lose access to for short periods of time if ever that single availability zone goes down. So it's about an extra 20% off the price from already the normal IA standard price. There is another one called the standard reduced redundancy storage. This one is kind of getting phased out as we speak because the same price for this storage class is about the same amount you're going to pay for the normal IA standard class. What this does is, again, is a good fit for your objects that you're not really worried about losing if there is some sort of catastrophe that happens in an availability zone. There's less copies of it that are stored, and so if that data center and that availability zone goes down, then you lose your object. So of course it offered at the time the highest price reduction possible, but now the difference between this one and the normal IA standard storage class is so small in terms of price that you're probably not going to migrate to or navigate to this storage class. But it is still there in the documentation, and it may very well come up still in the certification exam, so at least be aware of that. Let's now take a look at some individual features of S3, starting off with lifecycle management. So lifecycle management is very interesting because it allows us to come up with a predefined rule that will help us automate the transitioning of objects from one storage class to another without us having to manually copy things over. Of course, you could imagine how time-consuming that would be if we had to do this manually. So we're going to see this very soon in a lab. However, let me discuss how this works. So once it's basically a graphical user interface. It's very, very simple to use once you come up with these lifecycle management rules. But you're going to define two things. You're going to define the transition action and the expiration action. So the transition action is going to be something like, well, I want to transition an object from, maybe it's all objects, or maybe it's just a specific type of object in a folder, example, that has a specific prefix, from one storage class, let's say standard, to standard inactive or infrequent access. Maybe only after 45 days, after at least a minimum of 30 days, like we spoke of before. And then maybe after 90 days, you want to transition the objects in IA to right away Glacier Deep Archive, or 180 days. You come up with whatever combination you see fit, okay? It doesn't have to be sequential from S3 to IA to one zone, etc., because like we discussed before, it depends what kind of objects that you're interested in putting in one zone, objects that you don't really mind losing if that one availability zone goes down. So you're going to be deciding those rules. It ends up that this even is not a simple task because you have to monitor your usage patterns to see which data is hot, which data is cold, and what's the best kind of lifecycle management to implement to reap the benefits of the lowest cost. So you have to put somebody on this job and make the best informed decisions based on your access patterns, and that is something that you need to consistently monitor. So what we can do is we can instead opt for something called S3 intelligent tiering, which basically analyzes your workload using machine learning algorithms. And after about a good 30 days of analyzing your access patterns, we'll automatically be able to transition your objects from S3 standard to S3 standard infrequent access. Okay, it doesn't go past the IA one, it doesn't go after the Glacier and whatnot. Okay, so it can then offer you that at a reduced price overhead. So there is a monitoring fee that is introduced in order to implement this feature. It's a very nominal, very low monitoring fee. And the nice thing is if ever you take out an object out of the infrequent access before the 30-day limit, as we spoke of before, you will not be charged an overhead charge because of that. Why? Because you're using the intelligent tiering. You're already paying an overhead for the monitoring fee. So at least in that sense, the intelligent tiering will take the object out of IA and put it back into the S3 standard class if you need access to it before the 30 days. And in that case, you won't be charged that overhead. So that is something that is very good to do in order not to have to put somebody on that job. So yes, you're paying a little bit of overhead for that monitoring fee, but at the other side of the spectrum, you're not investing in somebody working many hours to monitor and put into place a system to monitor your data access patterns. So let's take a look at how to do this right now. Let's implement our own lifecycle management rules. So let's now create a lifecycle rule inside our bucket. First off, we're going to need to go to the management tab in the bucket that we just created. And right on the top, you see right away, lifecycle rule. We're going to create lifecycle rule and we're going to name it. So I'm just going to say something very simple, like simply learn lifecycle rule. And we have the option of creating this rule for every single object in the bucket, or we can limit the scope to a certain type of file, perhaps with a prefix like, I could see one right now, something like logs. So anything that we categorize as a log file will transition from one storage tier to the next as per our instructions. We're doing this because we really want to save on costs. Right? It's not so much of organizing what's your older data versus your newer data. It's more about reducing that storage cost as your objects get less and less used. So in this case, logs are a good fit because perhaps you're using your logs for the first 30 days, you're sifting through them, you're trying to get insights on them, but then you kind of move them out of the way because they become old data and you don't need them anymore. So we're going to see how we can transition them to another pricing tier, another storage tier. We could also do this with object tags, which is a very powerful feature. And in the lifecycle rules action, you have to at least pick one of these options. Now, since we haven't enabled versioning yet, what I'm going to do is just select transition the current version of the object between these storage classes. So as a reminder of what we already covered in the slides, our storage classes are right over here. So the one that's missing is obviously the default standard storage class, which all objects are placed in by default. So what we're going to say is this. We want our objects that are in the default standard storage class to go to the standard inactive access storage class after 30 days. And that'll give us a nice discount on those objects being stored. Then we want to add another transition, and let's say we want to transition them to Glacier after 90 days. And then as a big finale, we want to go to Glacier Deep Archive. You can see the rest are grayed out. Wouldn't make sense to go back. And maybe after 180 days, we want to go there. Okay. Now there's a little bit of a warning or a call to attention here. They're saying if you're going to store very small files into Glacier, not a great idea. There's an overhead in terms of metadata that's added, and also there's an additional cost associated with storing small files in Glacier. So we're just going to acknowledge that. Of course, for the demonstration, that's fine. In real life, you don't want to store very big tar files or zip files that had, one or more log files in there. Okay, that would bypass that surcharge that you would get. And over here, you have the timeline summary of everything we selected up above. So we have here after 30 days, the standard inactive access, after 90 days, Glacier, and after 180 days, Glacier Deep Archive. So let's go and create that rule. All right, so we see that the rule is already enabled, and at any time you could go back and disable this if ever you had a reason to do so. We can easily delete it as well, or view the details and edit it as well. So if we go back to our bucket, now what I've done is created that prefix with the /logs. Since we're not doing this from the command line, we're going to create a logs folder over here that will fit that prefix. So we're going to create logs, create folder. And now we're going to upload our, let's say, Apache log files in here. So we're going to upload one demonstration Apache log file that I've created with just one line in there, of course, just for demonstration purposes. We're going to upload that. And now we're going to just close that. And now we have our Apache log file in there. So what's going to happen, because we have that lifecycle rule in place, after 30 days, any file that has the logs prefix, or basically is placed inside this folder, will be transitioned as per that lifecycle rule policy that we just created. So congratulations, you just created your first S3 lifecycle rule policy. Let's now move over to bucket policies. So bucket policies are going to allow or deny access to not only the bucket itself, but the objects within those buckets to either specific users or other services that are inside the AWS network. Now, these policies fall under the category of IAM policy. So IAM stands for Identity and Access Management. And this is a whole other topic that deals with security at large. So there are no services in AWS which are allowed to access other services or data, for example, within S3, without you explicitly allowing it through these IAM policies. So one of the ways we do that is by attaching one of these policies, which are written in a JSON format. So it's a text file that we write. At the end of the day, that's the artifact, and that's a good thing because we can use that artifact and we can configuration control it in our source control and version it and put it alongside our source code. So when we deploy everything, it is part of our deployment package. So in this case here, we have several ways of doing this. We can use what's called the policy generator, which is a graphical user interface that allows us to simply click and point and populate certain text boxes, which will then generate that JSON document that will allow us to attach that to our S3 bucket. And that will determine, like I said, which users or services have access to whatever API actions are available for that resource. So we might say we want certain users to be able just to list the contents of this bucket, not necessarily be able to delete or upload new objects into that bucket. So you can get very fine-grained permissions based on the kind of actions you want to allow on this resource. So in order to really bring this home, let's go and perform our very own lab on this. Let's now see how to create an S3 bucket policy. Going back to our bucket, we're now going to go into permissions. So the whole point of coming up with a bucket policy is that we want to control who or what, the what being other services, have access to our bucket and our objects within our bucket. So there are several ways we can go about doing this. Let's edit a bucket policy. One, we can go and look at a whole bunch of pre-canned examples, which is a good thing to do. Two, we could actually go in here and code the JSON document ourselves, which is much more difficult, of course. So what we're going to do is we're going to look at a policy generator, which is really a form-based graphical user interface that allows us to generate, through the answers that we're going to give here, the JSON document for us. First question is, we got to select the policy type. Of course, we're dealing with S3, so it makes sense for us to create an S3 bucket policy. The two options available to us are allowing or denying access to our S3 bucket. Now, in this case here, we could get really fine-grained and specify certain kinds of services or certain kinds of users. But for the demonstration, we're just going to select star, which means anything or anybody can access this S3 bucket. All right. Now, depending on also the actions that we're going to allow. So in this case here, we can get very fine-grained, and we have all these checkboxes that we can check off to give access to certain kind of API action. So we can say we want to give access to, just deleting the bucket, which obviously is something very powerful, but you can get more fine-grained. As you can see, you have more of the getters over here, and you have more of the listing and the putting new objects in there as well. So you can get very fine-grained. Now, for demonstration purposes, we're going to say all actions. So this is a very broad and wide-ranging permission, something that you really should think twice about before doing. We're basically saying we want to allow everybody and anything, any service, all API actions on this S3 bucket. So that's no small thing. We need to specify the Amazon resource name, the ARN of that bucket specifically. So what we're going to do is go back to our bucket, and you can see here the bucket ARN. Okay, so we're just going to copy this, paste it in this policy generator, and just say add statement. You can see here kind of a resume of what we just did, and we're going to say generate policy. And this is where it creates for us, and make this a little bit bigger for us, it creates that JSON document. So we're going to take this, we're going to copy it, and we're going to paste it into the generator. Okay. Now, of course, we could flip this and change this to a deny, right? Which would basically say we don't want anybody to have access, or anything, any other service to have access to this S3 bucket. We could even say /star to also encapsulate all the objects within that bucket. So if I save this right now, you have a very ironclad S3 bucket policy, which basically denies all access to this bucket and the objects within. Of course, this is on the other side of the spectrum, very, very secure. So we might want to, for example, host a static website through our S3 bucket. So in this case here, allowing access would make more sense, right? So if I save changes, you see that we get an error here saying that we don't have permissions to do this. And the reason for that is because it realizes that this is extremely permissive. So in order to give access to every single object within this bucket, as in the case that I was stating of a static website being hosted on your S3 bucket, it would be much better to also at first enable that option. So I'm just going to duplicate the tab here. And once you go back to the permissions tab, one of the first things that shows up is this block public access setting, right? Right now it's completely blocked, and that's what's stopping us from saving our policy. We would have to go in here, unblock it, and save it, right? And it's also kind of like a double clutch feature. You have to confirm that just so you don't do that by accident, right? So now what you've effectively done is you've really opened up the floodgates to have public access to this bucket. It's something that can't be accidentally done. It's kind of like having to perform these two actions before the public access can be granted. Now, historically, this was something that AWS was guilty of, was making it too easy to have public access. So now we have this double clutch. Now that this is enabled or turned off, we can now save our changes here successfully. And you could see here that now it's publicly accessible, which is a big red flag that perhaps this is not something that you're interested in doing. Now, if you're hosting a public website and you want everybody just to have read access to every single object in your bucket, yes, this is fine. However, please make sure that you pay very close attention to this type of access flagged over here on the console. So congratulations, you just got introduced to your first bucket policy, a permissive one, but at least now you know how to go through that graphical user interface through the policy generator and create them and paste them inside your S3 bucket policy pane. So let's continue on with data encryption. So any data that you place in S3 bucket can be encrypted at rest very easily using an AES 256 encryption key. So we can have server-side encryption. We could have AWS handle all the encryption for us, and the decryption will also be handled by AWS when we request our objects later on. But we could also have client-side encryption where we, the client that are uploading the object, have to be responsible for also passing over our own generated key that will eventually be used by AWS to then encrypt that object on the bucket side. Of course, once that happens, then the key is discarded, the client key is discarded, and you have to be very mindful that since you've decided to handle your own encryption, client-side encryption, that if ever you lose those keys, well, that data is not going to be recoverable in that bucket on the AWS network. So be very careful on that point. We can also have a very useful feature called versioning, which will allow you to have a history of all the changes of an object over time. So versioning sounds exactly how it's named. Every time you make a modification to a file and upload that new version to S3, it will have a brand new version ID associated with that. So over time, you get a sort of stack of a history of all the file changes over time. So you can see here at the bottom, you have an ID with all these ones, and then an ID with 121212. So eventually, if ever you wanted to revert back to a previous version, you could do so by accessing one of those previous versions. Of course, versioning is not an option that's enabled by default. You have to go ahead and enable that yourself. It is an extremely simple thing to do. And so there may be a situation where you already have objects within your buckets and you only then enable versioning. Well, versioning would only apply to the new objects that would get uploaded from the point that you enabled versioning. The objects that were there before that point will not get a specific version number attached. In fact, they will have a sort of null marker version number that will get attached to them. It's only after that you modify those objects later on and upload a new version that they will get their own version numbers. So right now, what we're going to be doing is a lab on actual versioning. So let's go ahead and do that right now. In this lab, we're going to see how to enable versioning in our buckets. Enable versioning is very easy. We're simply going to click on our bucket, go into properties, and there is going to be a bucket versioning section. We're going to click on edit and enable it. Once that's done, any new objects that are uploaded to that S3 bucket will now benefit from being tracked by a version number. So if you upload objects with the same file name after that, they'll each have a different version number. So you'll have version tracking, a history of the changes for that object. Let's actually go there and upload a new file. I'll upload one called index.html. So we're going to simulate a situation where we've decided we're going to use an S3 bucket as the source of our static website to deploy one. And in this index.html file, if you take a look right now, let's take a look at what's in there. You can see that we have welcome to my website and we're at version 2. Okay, so if I click on this file right now and I go to versions, I can clearly see that there's some version activity that's happening here. Okay, we have here at 1456, which is the latest one is on the top, the current version, we have a specific version ID. And then we have a sort of history of what's going on here. Now, I purposely enabled versioning before and then try to delete versioning or disable versioning. But here's the thing with versioning. You cannot disable it fully once it's enabled. You can only suspend it, right? Now, suspending means that whatever version numbers those objects had before you decided to suspend it will remain. So you can see I have an older version here that has an older version number. And at this point here, I decided to suspend versioning. And so what it does, instead of disabling the entire history, it puts what's called a delete marker, okay? You could always roll back to that version if you want. Now, in the demonstration, when we started it together, I enabled it again. So you can see this is actually the brand new version number as we did it together, but you don't lose the history of previous versioning if ever you had suspended it before. So that's something to keep in mind, right? And it'll come up in the exam where they'll ask you, can you actually disable versioning once it's enabled? And the answer is no, you can only suspend it and your history is still maintained. Now, we have that version there, and let's say I come to this file and I want to upgrade this, I don't know, I say version 3, right? And now what's going to happen is if I click on this version, just as the current one with version 2, and I open this, we should see version 2, which is fine. That's expected. If we go back to our bucket and upload that new version file that has version 3 in there, the one I just modified, we should now see in that index.html file a brand new version that was created under the versions tab. And there you go, 1458, just 2 minutes after. You can see here we have a brand new version ID, right? And if I open this one, you can see version 3. So now you have a way to enable versioning very easily in your buckets. And you also have seen what happens when you want to suspend versioning, what happens to the history of those versions files before. Just to actually go back here to the properties where we enabled versioning in the first place, if I want to go back in here and disable it, like I said, you can't disable, you can only suspend. And that's where that delete marker gets placed, but all your previous versions retain their version ID. So don't forget that, because that will definitely be a question on your exam if you're interested in taking the certification exam. So congratulations, you just learned how to enable versioning. Let's move on to cross-region replication, or CRR as it is known. There will be many times when you find yourself with objects in a bucket and you want to share those objects with another bucket. Now that other bucket could be within the same account, could be within another account within the same region, or could be within a separate account in a different region. So there's varying levels of degree there. The good thing is all of those combinations are available. So CRR, if we're talking about cross-region replication, is really about replicating objects across regions, something that is not enabled by default because that will incur a replication charge because it's syncing objects across regions. Of course, you are spanning a very wide area network in that case, so there is a surcharge for that. Now, doing so is quite simple to do, but one of the things that we have to be mindful of is to give permissions for the source bucket, which has the originals, to allow for this copying of objects to the destination bucket. So if we're doing this across regions, of course, we would have to come up with IAM policies, and we would also have to exchange credentials in terms of IAM user credentials, in terms of account IDs and the such. We're going to be doing a demonstration in the same account, in the same region, but largely this would be the same steps if we were going to go cross region. So this is something you might find yourself doing if you want to share data with other entities in your company. Maybe you're a multinational and you want to have all your log files copied over to another bucket in another region for another team to analyze, to extract business insights from. Or it might just be that you want to aggregate data in a separate data lake in an S3 bucket in another region, or in like I said, it could be even in the same region or in the same account. So it's all about organizing, moving data around across objects, across these boundaries. And let's actually go through a demonstration and see how we can do CRR. Let's now see how we can perform cross-region replication. We're going to take all the new objects that are going to be uploaded in the Simplilearn S3 demo bucket, and we're going to replicate them into a destination bucket. So what we're first going to do is create a new bucket, okay? And we'll just tack on the number 2 here. And this will be our destination bucket where all those objects will be replicated to. We're going to demonstrate this within the same account, but it's the exact same steps when doing this across regions. One of the requirements when performing cross-region replication is to enable versioning. So if you don't do this, you can do it at a later time, but it is necessary to enable it at some point in time before coming up with a cross-region replication rule. All right, so let me create that bucket. And now after the bucket is created, I want to go to the source bucket and I want to configure under the management tab here a replication rule. So I'm going to create a replication rule, call it Simplilearn rep rule. And I'm going to enable this right off the bat. The source bucket, of course, is the Simplilearn S3 demo. We could apply this to all objects in the bucket or perform a filter once again. Let's keep it simple this time and apply to all objects in the bucket. Of course, caveat here, this will only now apply to any new objects that are uploaded into this source bucket and not the ones that are already pre-existing there. Okay. Now, in terms of a destination bucket, we want to select the one we just created. So we can choose a bucket in this account, or if we really want to go cross region or another account in another region, we could specify this and put in the account ID and the bucket name in that other account. So we're going to stay in the same account. We're going to browse and select the newly created bucket. And we're also going to need permissions for the source bucket to dump those objects into the destination bucket. So we can either create the role ahead of time or we can ask this user interface to create a new role for us. So we'll opt for that and we'll skip these additional features over here that we're not going to talk about in this demonstration. We're just going to save this. So that will create our replication rule that is automatically enabled for us right now. So let's take a look at the overview here. You can see it's been enabled. Just to double check, the destination bucket is the demo 2. We're talking about the same region. And again, here we could opt for additional parameters like different storage classes in the destination bucket that object is going to be deposited in, et cetera, et cetera. For now, we just created a simple rule. Now, if we go back to the original source bucket, which we're in right now, and we upload a new file, which will be a transactions file in a CSV format, once this is uploaded, that cross-region replication rule will kick in and will eventually, right, it's not immediate, but will eventually copy the file inside the demo2 bucket. Now I know it's not there already, so what I'm going to do is pause the video and come back in 2 minutes, and when I click on this, the file should be in there. Okay, so let's now double check and make sure that object has been replicated. And there it is, been replicated as per our rule. So congratulations, you just learned how to perform your first same account S3 bucket region replication rule. Let's now take a look at transfer acceleration. So transfer acceleration is all about giving your end users the best possible experience when they're accessing information in your bucket. So you want to give them the lowest latency possible. You can imagine if you were serving a website and you wanted people to have the lowest latency possible. Of course, that's something that's very desirable. So in terms of traversing long distances, if you have your bucket that is in, for example, the US East 1 region in the United States, in the Virginia region, and you had users, let's say in London, that want to access those objects, of course, they would have to traverse a longer distance than users that were based in the United States. And so if you wanted to bring those objects closer to them in terms of latency, then we could take advantage of what's called the Amazon CloudFront Delivery Network, the CDN network, which extends the AWS backbone by providing what's called edge locations. So edge locations are really data centers that are placed in major city centers where our end users mostly are located, more densely populated areas, and your objects will be cached in those locations. So if we go back to the example of your end users being in London, well, they would be accessing a cached copy of those objects that were stored in the original bucket in the, for example, US East 1 region. Of course, you will get most likely a dramatic performance increase by enabling transfer acceleration. It's very simple to enable this. Just bear in mind that when you do so, that you will incur a charge for using this feature. The best thing to do is to show you how to go ahead and do this. So let's do that right now. Let's now take a look at how to enable transfer acceleration on our Simplilearn S3 demo bucket. By simply going to the Properties tab, we can scroll down and look for a heading called Transfer Acceleration over here, and very simply just enable it. So what does this do? This allows us to take advantage of what's called the Content Delivery Network, the CDN, which extends the AWS network backbone. The CDN network is strategically placed into more densely populated areas, for example, major city centers. And so if your end users are situated in these more densely populated areas, they will reap the benefits of having transfer acceleration enabled because the latency that they will experience will be severely decreased. So their performance is going to be enhanced. If we take a look at the speed comparison page for transfer acceleration, we can see that once the page is finished loading, it's going to do a comparison. It's going to perform, first of all, what's called a multi-part upload, and it's going to see how fast that upload was done with or without transfer acceleration enabled. Now this is relative to where I am running this test. So right now I'm actually running it from Europe. So you can see that I'm getting very, very good results if I would enable transfer acceleration and my users were based in Virginia. So of course now I have varying differences in percentage as I go closer or further away from my region where my bucket or my browser is being is being referenced. So you can see here, United States, I'm getting pretty good percentages. As I go closer to Europe, it gets lower, of course, but still very, very good. Frankfurt again, this is about probably the worst I'm going to be getting here since I'm situated in Europe. And of course, as I go look more towards the Asian regions, you can see once again it kind of scales up in terms of better performance. So of course, this is an optional feature. Once you enable it, as I just showed over here, this is a feature that you pay additionally for. So bear that in mind. Make sure that you take a look at the pricing page in order to figure out how much this is going to cost you. So that is it. Congratulations. You just learned how to simply enable transfer acceleration to lower the latency from the end user's point of view. We're now ready to wrap things up in our conclusion and go over at a very high level what we just spoke about. So we talked about what S3 is, which is a core service, one of the original services published by AWS in order for us to have unlimited object storage in a secure, scalable, and durable fashion. We took a look at other aspects of S3 in terms of the benefits. We mainly focused on the cost savings that we can attain in S3 by looking at different storage classes. Now, of course, S3 is industry recognized as one of the cheapest object storage services out there that has the most features available. We saw what goes into the object storage in terms of creating first our buckets, which are our containers, high-level containers in order for us to store our objects in. Again, objects are really an abstraction of the type of data that are in there, as well as the metadata associated with those objects. We took a look at the different storage tiers, the default being the standard, all the way till the cheapest one, which is the Glacier, which are meant for long-term archived objects. For example, log files that you may hold on to for a couple of years, may not need to access routinely, and will have the cheapest pricing option by far. So we have many pricing tiers, and if you want to transition from one tier to the next, you would implement a lifecycle policy or use the intelligent tiering option that can do much of this for you. We took a look at some very interesting features, starting from the lifecycle management policies that we just talked about, all the way to versioning, cross-region replication, and transfer acceleration. So with this conclusion, you are now ready to at least start working with S3. And if you want to learn more about S3 and all other services in AWS, you can refer to the Simplilearn website for more information at www.simplilearn.com. I look forward to seeing you there. Thank you and have yourself a great day.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.